not attend the session, free does not mean you will not attend the session, you will not attempt your quizzes, you will not attend you will not do the assignments. For me, that's not the definition of free. Free for me does not mean you're just joining a group and showing me a number that you are a member of the group. Sorry. That does not mean to me. You have to participate, you have to be active. If I'm giving you something for free, please value it. Give it a value. Learn. If I don't find people participating, if I don't find people attending sessions, or they're not active, they're not interested, I'm sorry, I will deactivate you. As I said, if someone is giving you something free, is working hard for you, I'm investing a lot. Even when I'm giving you something free, I'm investing a lot. For you, it's a free program. For me, it's not free. So please, let's make sure that we add value to the program. For instance, I can see 175 people in the group, but I can only see 23 people attending the session. That is discouraging. That is demotivating. And then when you go on Facebook, when you go on Instagram, you keep asking for support, you keep asking for help. But when someone is helping you, actually you're not interested. You're not interested, trust me. Anyway, that is up to you. That's your career. That's your growth. I leave it to you. So let's start with types of data. Why type of data is very important. Just give me 1 second, okay? Give me actually I'm trying to come to the board to write, but I'm facing some injury problem, that's why. But I'll come to the board now. Types of data. This is the basic, this is the foundation. If we don't understand the type of data, why we will fail? One, your analysis. Your analysis will be wrong. If you don't understand the types of data, your analysis will be wrong. You will not be able to work or create a dashboard on Tableau or Power BI. You will not be able to run the right tests. Right tests on R and Python or other statistical platform wherever you're working. You will face challenges if you don't understand the concept or the fundamentals of types of data. It also means that if I cannot differentiate between a cat and a dog, I will not be able to identify when I'm going to purchase a cat and a dog. You must identify between, you must be able to differentiate between a cat and a dog. That's the reason you must be able to differentiate between the types of data that we have. So now, what are the types of data? One, we all understand. Structured And the second is unstructured data. Unstructured data means your images, music, photos, words. I mean, any data which does not have a structure or a column or a tabular format, they are unstructured data. So we are not talking much on the unstructured data. What we are going to talk on is on the structured data. Structured data means tabular format, where we all know this is the most common thing, right? This is your variable 1, variable 2, variable 3, and this your, let's say, response. Why? This is your response, which is also called Y. These are your variables which are called X. So this is the type of data we all often see: 2, 4, 3, 10, whatever, 2, 8, 9, in a tabular format. Right? This is a common data that we all come across, where we can see columns and we have rows. Right? We have columns and we have rows. So the tabular format, where we have rows and columns, that's the type of data we are going to discuss. Then what are the types of data under this structured data? Let's discuss this. We all must understand quantitative. The second is qualitative data. One is quantitative and the second is qualitative. By the word itself, it is very clear if you break the word. We know here we are talking about quantity, number. Here we are talking about quality, right? It is very clear. Here we are talking about numbers. Here we are talking about quality. Let's understand a very, very simple way. Whenever we have numbers in our data, that is a quantitative data. Whenever we have, let's say, excellent, very good, average, poor, or you have a rating of 5, 4, 3, 2, 1. Wherever you have these ratings, this is the qualitative data, or which we'll further drill down, and when we learn this, we learn as a categorical data. So understand the difference between qualitative and quantitative data. Let's further break down quantitative and qualitative data. When we talk about numbers, we say the number, it can be an integer and it can be a continuous, or what we call a number with decimal. So when we talk about numeric number, or you say numeric data, we divide them into integer and continuous. We all understand what is integer. Integer means any number 1, 2, 3, 4, where you don't have any decimal. No decimal. 1 is 1, 2, 3, 4, we can count. Let's understand this continuous data. Why is it called continuous data? If I say 2.54 or 1.001, any number with the decimal will have is called continuous data. And this type of data is the best used for analysis. Why? Because it's giving you more and more scope to analyze. You can get into the depth of analysis by using more and more decimals. But the question is, why is it continuous data? You will be asked in your interview. The very basic question you'll be asked in your interview, why is it called a continuous data? It's called a continuous data because between 1 and 2, let's say this is a number 1.001. Between 1 and 2, there are infinite values. This is a continuous number. There are continuous numbers between 1 and 2, infinite. It can be 1.00001, 1.99999. So between 1 and 2, there are infinite values. That is why it's called continuous. There's a continuous number between 1 and 2. So between number 1 you have integer, the second is your continuous. Under the qualitative, you call this quality data, under which we will also learn later about the ordinal. When you say ordinal, you can figure out order means order. Means the best is excellent. After that comes very good. After comes that. We all know that 5 is more than 4. We all know 4 is greater than 3. So this is ordinal. Excellent is better than very good. This is ordinal. Right? If I say 1 and 0, 1 and 0 is a binary. It's a binary number. If I say yes and no, this is dichotomous. It's either yes or no. If I change this to 1, if I change this to 0, it's called binary. We all know what is binary. Then, if I say any name, Anup, Subodh, Abdul, this is nominal. We're just writing names. It has no value if I don't change them into something, if I don't extract some information. This sort of data, this is called categorical or discrete. When we say discrete, what does it mean? The word English, if you talk about the English meaning, it means something unique. If it means, let me give an example. If I can have 2 books, I can have 4 books. I may not have 2.5 books. I may not have 4.2 books. I will not have 2.22 books. It means it's a discrete number. I can differentiate between the number of books that I have. Either I have 2 books or I have 4 books. And we will learn, and as we go on applying them, we will learn the definition, the application, and the significance of these types of data when we start applying them on certain data set for analysis. So, under the qualitative, we are talking about categorical, we are talking about discrete, and we are talking about binary, we are talking about dichotomous, we are talking about nominal. Under the continuous, we talked about now. When we talk about continuous, there's a universal term. On RStudio, on Python, you will get these in different terms. In RStudio, you will have this as NUM, and we will see them on RStudio. Don't worry, on Python. On Python, you will see the same thing, which is called float. RStudio is the same thing. RStudio is a different brand. Python is a different brand. RStudio calls it NUM, numeric. Python calls it float. Okay, but the type of data is same. When you go to categorical data, which we will see, when you go to categorical data, RStudio is called numeric, or it may also call integer. And the categorical data, you see RStudio, R will say, we'll call it factor. Python will call this object. And as we learn, we will practice, you will get these differences. It's just a name given on different platforms. Universally, as a universal name, you know this as categorical, you know this as continuous. You will hear this discrete, you'll hear this numeric. Now, let us understand the basic difference between integer and the continuous. And when do we apply this? What is the probability that you will get confused when you get the real data? When you get this integer and when you get this continuous. And please pay attention to this. This is an integer and this is continuous data. 1, 2, 3, 4, 5. This is an integer. 1.25, 2.23, 3.001, 4.0002, 5.222, whatever, right? This is my integer, this is my continuous. What R or Python, how they understand the number? If my R or Python, in my data, they see no decimal. If they see no decimal, they will call it, they will identify this as integer. If they see some decimal in my data, they will call it as continuous number or float according to R and Python. When it comes to the analysis, we will discuss how and when to convert the data to different types. The reason being, why we are trying to learn the different types of data, why is it important in your data every day at your desk? Why is it important that when you're trying to become a data analyst, why do you have to learn this as a basic? Because the moment you open your Excel sheet and you try to do some analysis using some tools on your Excel or Python, you must understand that certain tools will accept only certain types of data. For instance, if you try to plot histogram, it will only accept continuous data. It will not accept a categorical data, please. If your R or Python is calling it a categorical or factor, histogram will refuse to take the factor. It'll refuse to take it. If you are plotting a box plot, it will only accept continuous data. It will not accept any discrete or categorical data. If you are trying to plot, if you are trying to run certain tests, which we will learn as we move forward, when we are trying to run some tests, you have to ensure that you put in the right type of data for your X and Y. If you don't put in the right type of data, the platform will refuse to accept your test. Now we come across many people saying, I've learned Tableau, I'm learning Power BI. But let me tell you guys that if you don't understand these basics, if you don't understand this, if you don't understand this, you will face a lot of challenges in Tableau or Power BI, because you will not be able to select the visualization or the plots or the graphs if you don't understand the types of data. Because Tableau or Power BI, they will expect you they expect you to know the type of data so that you can select the right type of graph or the plots for visualization, which we will see today. So this is the basic of types of data that we are talking about, and we will learn as we move ahead with R and Power BI and Tableau. So let me show this on R right now, because I don't want to show everything on R, Python, everything on one day. Otherwise, if we rush, you will not be able to understand anything. Even though we have some time limitation, but let's try and understand the basics. So let me open R and show you the types of data and how we interpret. Just give me a moment. The other day, we saw R. We had an overview of R Studio. Maybe many people, many of you have not, you were not there, but please do go through the videos where we had introduced you to R. And today, and gradually, we will start practicing on R. So we had learned the other day how to upload the data from here. We have uploaded the data on R. Let me upload it again for you. Very simple, the way we upload on Excel, the way we upload on other windows. There's nothing very different. This is my data I'm uploading from my file. This is the data which you uploaded from my console. I'm copying it. I'm pasting it. You can see all these things we have done in the last session, and as we go, we practice. You can watch the video. I can name it, I can give it any name. I can give any name, I'm just giving it a name. Saving my data somewhere. I'm giving it a name, serve level. And when I run, if I don't see any red, any error, it means I've uploaded my data successfully. Now, what I'm talking about is the structure or the types of data. So when I have to see my structure of the data, types of data, I say str, which is called structure in R. str, that's very easy, very intuitive. str, I give the name of my data. You just type in one or two letters and it will throw the names of your data. And I say, okay, let's focus today on types of data, not on the coding. Coding and all is very easy. You will get it within 15 days if you practice. Very, very easy. It's more like, typing English. So this is the type of data that we have. when we talk about the structure of the data, it says there are 1,124 observation or rows. Observation means rows. And 7 variables, 7 columns. So let's see the data. This is my data. How many rows are there? 1,124. How many columns are there? 2, 3, 4, 5, 6, 7 columns. And this is what my data is saying. This is what my R is saying. Now it says character. This is a string. Say character A, B, C, D, E. So it says CHR is a character string. Year is telling me because it's saying me integer. But year cannot be integer. It will be a date. Why is it calling integer? Because it's seeing a number 2017 with no decimal. And it's not giving any date format. So it's calling it integer, which I will change it to maybe factor or date, which we can change. So let's say, I say, no, this is not integer. I want to change it to date. You know what? I'll tell R, please change it to date. After this is not integer. Fine. So very easy, very easy. I take my data, this is my data. When I say a dollar, when I put a dollar sign, you will get all the variables over here. All the variables. So what I'm saying, you know what? Here, change it to factor. Change it to factor or text. So service level, year, and I say as dot factor. The moment you say as dot FSC key factor, this is what you have to remember. Like Excel, you need to remember what you want to do. In order to do something, you must understand what you need to type once, little bit. As dot factor, again I say serve level, data, and I say dollar sign, and it gives me year. And I say, okay, run. I'm running it. Now if I see the structure of the data, year has changed to factor. Now you see, year has changed to factor with 4 levels. Means I have data of 2017, 18, 19, and 20. There's 4 levels. So I've changed the year to factor. Now, you see the num. NUM means number. I told you that if there are decimals, R will take it as a number, NUM. Python will take it as a float. If there was no number, it would take it as an integer. If there was no decimal, it would take it as an integer. So this is how we identify in R, how the R identifies the number as a different types of data. So this is a continuous data. This is a categorical data. This is we call a string character, not much in use. So this is an R. And you have to, there's a lot more about the type of data which you need to practice. We have to explore much more than what I'm telling you now. And as we go ahead, as we practice our statistics, our analysis, this type of data will be very prominent, and we will have to learn. We have to learn the right approach, right application in your office, at your desk every day. So, just giving you an example. If I have to draw a box plot, and if I tell R you do a box plot with a factor data here, it will not do anything. It will not do anything because it said no, it's a factor data, I cannot do that. I need a continuous data. Service level year, because my year is factor. If I ask it to draw, what is it doing? It's still taking as number. Now if I say with a continuous number, You have to be very careful with R. I have changed this to year. After changing this to year, my service, my structure of data is this. Now, if I ask the box plot, it might give me an error. It might give me an error. Let's see if it gives me an error. Three, two, four. Anyway, it doesn't make any sense because it's taking me year one, year two, all the 4 levels. Okay. I wanted to see 2017, 2018, which is not give me until unless I change my plot. So, and I think we had discussed box plot last time. We had discussed box plot last time, I think, in our last. This is my data. So I'll discuss what are these outliers, how do we study all these things. We will learn. So this was a type of data in brief. And keeping the time limit in mind, we'll discuss more as we practice. Let's move to a little bit of Tableau. But before going to Tableau, let me ask you if you have any question on this so far, so that I can just answer 1 or 2 people and we can move ahead. Any question on types of data? Anyone? Please become interactive. Please participate. We all are learning together. Nobody's right, nobody's wrong. You must interact, but must participate. So let's move to Tableau overview. I can see a chat. It says categorize a category of which data. So it depends. Let's say year. It's a category of year which is like 2017, 2018, 2019, 2020. So when you have a category, you can have excellent, very good, good, average, poor. That's a category. You can also have a rating of 5, 4, 3, 2, 1. That's a category in which entire data will have a only number 5, 4, 3, 2, 1. Again, repeatedly 5, 4, 3, 2, 1. So if you have certain limited category, that is a categorical data. That category can be in form of integer. Category can be in form of your character also. Which as we go ahead, we will learn. So now let's go to Tableau and understand the features. But before that, let me explain that why Tableau is important and what are the limitations of Tableau if you don't go hand in hand. I come across many people and they say, sir, I have learned Tableau, I have done Power BI. Can I become a data analyst? It's not that you cannot become a data analyst, but then you are actually limiting your growth towards data analyst. What is the meaning of data analyst? Data analyst means you are analyzing the data. You are analyzing data. You are not just visualizing data. Visualizing data is different from analyzing data. Tableau gives you a platform to visualize data after analyzing data or analyze data after visualizing data. If you just visualize it, you can visualize on Excel also. If I draw this graph and I say, this is my graph, okay? I can, anyone of grade 8, grade 6, anyone can put it on this Excel and say, I've created a plot, I can visualize data. But there's no value in visualizing this data if you cannot understand that there's a trend over here. You cannot understand if the way I had discussed this in my last session about understanding, interpreting your control charts. If you cannot analyze, if you cannot read your graph, what you have visualized, Tableau becomes a limitation to you. You will not grow. So understanding the types of data, understanding the statistical analysis, understanding the outcome of basic statistics, descriptive statistics, understanding the control chart, and then when you're visualizing the data on Tableau or Power BI, you are actually then an analyst. So you're a data analyst when you know how to visualize and when you know how to analyze. Otherwise, Tableau is a limitation to you. So let's see Tableau, what it is all about. Again, it is a very, very easy platform, but it is a C. You can learn a lot and you can go from the scratch to a professional level. It depends how much you practice. But as I said, if you don't understand analysis, if you don't understand the statistical analysis of data, then Tableau is just like doing a MIS job or just creating a graph. That's it. So let's understand Tableau. You can download from website Tableau public. It's a web-based it's an application. So if I come over here, and I can pull in my data. When you say Tableau public, go to a website, Google, say Tableau public. You can download Tableau public. The moment you download Tableau public, you will come to this page. And then you can pull your data wherever you have your data from, just like Excel or R that we saw. You put in the data, you open it from here, and your data will be uploaded. I've already uploaded my data, so I'm not uploading again. I'm just taking you to something which we have already created. And you are actually saving all your files on cloud, Tableau cloud. So when you upload your data, you can see your data over here, data source. You can see your data over here. Okay, it's already uploaded, so don't worry. Now, Tableau has 3 components. You can do a lot of things on Tableau. One, you can visualize on worksheet where you are deciding what to visualize. Second, you can create dashboard. Third, you can create your stories. Let's understand this. This is like you're working on your own. You're creating pages from your data. You're creating different types of charts, graphs, tables from your data. What is a dashboard? It's very important to understand. People, if you ask 90% of people, they may not give you the right or required level of answer, the meaning of dashboard. So who can explain, who can try? What is a dashboard? You see a dashboard in your car, you see a dashboard on your bike, you also see a dashboard in your office. What is the meaning of dashboard? Who can just try? Who can just try and explain in 1 or 2 sentences? Try please. Anyone?
I think a dashboard is an information that tells about a system, a process, or something in particular, an information that gives you details about that thing specifically to what you are looking for. For example, the car dashboard tells you about your speed, about your fuel levels, the conditions of the vehicle. So you can have dashboard that can tell you about the situations of a system, what is happening there and what's going on currently or have happened in the past. I think that's what I think about dashboard.
Good, good. Anyone else who would like to try what is a dashboard? Subodh?
It's a tool which provides the information with complete I mean to say in one platform.
Very good. Very good. Samir? Ravi? Rawat? Pallavi?
Sir Abhishek.
Yeah, Abhishek.
So the dashboard which can gives different kind of information, different kind of data cuts that helps operation or processes to run and take their decision basis on the performance.
Very good. So what is the objective of a dashboard? Yes, Samir?
I was on the same lines, sir. Just trying to say like anything. It gives you a visual information of like what exactly is going on currently state, and it gives you an idea of what's going on.
Fine. That's what you people have said is right. Okay. So when we look at the dashboard on my car, I'm looking at it. But then what is the objective of looking at the dashboard consistently on my car? Every 10 minutes, every half an hour, I look at the dashboard of my car. What is the objective of looking at the dashboard?
May I, sir?
Yeah, please go ahead.
Yeah, it will be like canvas which will give you the information on the current scenario.
Okay.
Yeah, as your data is getting changed on the background, your information will be getting changed on your front end also.
Very good.
Correct.
Yes. So now what we are going to do with the dashboard and why we keep looking at dashboard is very important, especially in our business. We are waiting for a response. If there's anything, every metric, every measure has a target. When I'm driving, I ensure that my fuel in my car, it doesn't go below this. I must have half the tank of fuel. The moment I see moving down, I respond. I respond to this and I fill it up. So dashboard means you have a platform in office or in the CEO office, depending on the audience. They are looking at 4 to 5 key metrics or key KPIs or the KPIs, and the audience or whoever is looking at the metrics or the KPIs, they are immediately responding to it. If you don't respond to the changes, the dashboards of the story, it makes no sense. If my blog, if I'm presenting it for 1st of September, 2nd September, 3rd, 4th, 5th, if on first it was here, second it was here, on third if is here, on fourth if it is over here, on fifth if it is over here, it goes like this. Generally, what we do in our offices, we don't even care. We are looking at the data maybe after a week or after 15 days or after a month. But the purpose of the dashboard is to, the moment it is going from here, if it changes to this place, we have to respond. We have to ask for a response from the team or the management, whoever is responsible. That is the purpose, that is the objective of a dashboard. So if I have metric 1, KPI 2, KPI 3, 4, 5, if anyone is moving beyond the target for the day or for the week as defined, we have to respond. We have to raise queries, we have to create a noise in the system so that they respond. If you're not responding, creating a Tableau, creating a visualization on Tableau or Power BI, it doesn't make any sense. Why I'm saying this? Let's say you are working on Tableau and you are at a very junior level. Let's say you are at the entry level. And you know that you're visualizing your data and you can see your dashboard, something like this. You are thinking that I'm at the entry level. My job is to take the data, visualize it, and give it to the operation. That's what you feel. No, that's not only your job. You will only grow when you start highlighting this, that as per the target, these people have missed the target. You people need to respond. You have to ask the operation, why this gap? That is the time when your company will start recognizing you and start seeing your value add on Tableau. If you're just publishing a visualization and sending it to people without even annotating it or without even highlighting something, trust me, you are just a simple, what I can say, you're not even an MIS guy. You're not an analyst. You're not an analyst. Sorry. Analyst means you have to ask for a response, or you have to respond. Then why did this performance dip? You have to investigate. You have to tell the management. You have to tell the operation. That is the real job of an analyst, rather than just taking and visualizing data and passing it on. So if you see this, there are a lot of things you can do on Tableau and Power BI. They are same thing, You can create a new worksheet. You can create a dashboard. I will show you the storyboard. Here you can do a lot of analysis, and this will only help you if you understand analytics, if you understand statistical analysis, if you understand the type of data or type of tests, or you understand how to read the outcome from Python or R. Only then this part is important to you, and this is very, very important. You can also create a map, world map, international map. You can, the way you have to format you have to personalize your lines, cells, you can do that. Server is only, you can do it if you're not on a public platform. This is more, for people who are paying for it. And there's a window what you want on your platform. So they are very common things which we all know. From here you can create a worksheet. I click this. Let me take it up. So I can create a worksheet here. I can create this is a dashboard. Now, what is the difference between a dashboard and a worksheet? Let me explain to you. Worksheet is here when you are creating graphs, you are visualizing your data over here. Now, when you have visualized several data over here, and when you're creating a dashboard, you are bringing different types of visualization to one platform. to drill down. Let's say this is my sales profit under these categories. Now I want to see a profit trend for this category. I want to see a profit value. I want to see a subcategories under these sales profit. So you're trying to create a dashboard for one KPI and drill down, and the best part of Tableau and Power BI is very interactive. It's very interactive. Anyone can take control, and anyone can actually, you can give the control to the audience. So let's understand this. Now, let me create a new page. This is a new page, and these are my data again. Data type. You must understand the type of data. If you see this icon shows that it has you can have the longitude and latitude of different countries, different places. You can create map out of this. This indicates hierarchy, which we will talk. Here, ABC means it's a categorical data, text data. If you see the measure, if you see this measure, you will see this green. This is a continuous data. This is a continuous data. Then we will have something called a calculation, where we are calculating, we are trying to, derive something from two variables. Sale, good sale minus bad sale is equal to defect. So good sale minus the bad sale is equal to defect. We can create a variable. This is a date. Here you see the icon of a calendar, there's a date. So again, if you don't understand the type of data, you won't be able to do it. For instance, here you go show me. This will only work for you when you understand this. It says, if I click this, it says to get the map, you need one dimension, one or more dimension, one measure. What is a dimension? Dimension means the categorical data. Measure means the continuous data. If I click this, it says you need one zero dimension, one or more measures. So if I know the type of data, only then I'll be able to visualize, and that is very easy. So, and again, guys, it's a matter of playing. You have to play with it. The way we play with a new mobile, play with it, and you will learn a lot. So, let's say, I'm just taking this category of product, and I'm putting it over here. Okay, I put it over here. I can see a plus sign. It means there are hierarchies. What happens if I say plus? It says subcategory. It's giving me subcategory. I can still see a plus sign. The product name. Okay, that's it. Now I will take the sale. How much the sale for category, subcategory, and product. Okay. I'm just playing with it. I'm just trying to learn. Now I can see this. Maybe it's not looking, it's looking very clustered. So I may change the format. I'm not interested. I want remove the product from here. I just want category and subcategory. It looks better. I want, descending order. So very easy. I just click this. I get descending order. I want to change the color. You can change the color from here. Change the color. I change the color. So start playing with it. Now, here is a column, is a category. This is my measure on the rows. Let me change it. Let me bring this down and bring this up. Let's see how the graph changes. Okay. So you can play with this. See, now it has changed this direction. Furniture, and the furniture have the subcategories. If I want to add the product, I just plus, and I can add the product. I can put it in the ascending or descending order. Now, fine. I say, no, I don't want to see so many things together. No, it's becoming too much for me. I can put filters. So I say, I want to see state-wise, or I want to see country-wise. I take the country. And I put it over here. And I say all United States. Now if I say show filter, it will show me over here. Because it has only United States, that's why it's just showing you United States. Now, but thing is, okay, fine, remove this. I'm not interested in this one, United States. I want to see the regions. I put regions over here. And I say all. Use all. And I say show the filter. Now, what is the purpose? I say I don't want to see everything. I just want to see for East. I just want to see East. Works a little slow, sometimes, yeah. So I'm just seeing East. Right. So what about now? I'll say, okay, you know what? Remove this category from here, and I'll put the category in filter. Okay. I'll put the category under filter. I put the category under filter. And I say all. Now I want to see for East, and I want to see under East which are the categories which have good sales or highest sale. I say filter. Now I see under East, I just want to see furniture. So it show me under East which are the products, subcategories under furniture. And I want to see the sale, total sale. Or I want to see the average sale. I can go, I say measure, I'll just see the show me the average sale. That's it. So it will give you average sale. You can play with it, guys. There's a lot, and Tableau is very interesting, and so is Power BI. You can level your data, and you have a lot of things as we go. When we have the true session, when we have 3 to 4 sessions of Tableau, proper sessions of Tableau, we will understand everything. We will understand all these things, how to create the moving average. How to create this Pareto chart, 80%, 80-20 rule, the Pareto rule. How to create this, how to read this, how to understand this regression. If I create this, how do I understand? You can only understand this when you understand the p-value, when you understand the linear regression. And that is what I'm saying. Understanding analytics, understanding analysis, understanding statistical analysis is important if you really want to do very good with Tableau. So how we are going to learn regression, how we are going to do clustering, how we are going to do clustering on Tableau or Power BI. Everything is there. But you must understand how to interpret the data or your visualization. Only then you'll be able to make good of Tableau and you'll be able to grow in your career. It means, what am I trying to say? It means Tableau or Power BI or Python and the data analysis, the statistical analysis, they will always go together, and SQL. They will always go hand in hand to become a data analyst or a data scientist. You cannot say that I've done Tableau, I'll become a data analyst, or I've done SQL, I'll become a data analyst, or I've done only R or Python data analyst, I can become an analyst. No. All these skill sets have to go hand in hand to become a data analyst where you can get a good job in the market. So we will learn more on the Tableau maybe next week. We will have proper session. In the meantime, in case you want to go through Tableau, we have some videos on the platform for reference. You can watch these videos. There are 4 to 5 videos on end-to-end Tableau training. You can go through it. You also have the videos on Power BI. You can go through the Power BI, or you can wait for me to conduct these live sessions. Okay, so we can talk a lot on Tableau. You can watch the videos. Just wanted to introduce you to Tableau. Next session, I'll introduce you to Power BI, and that's how we'll move ahead. Now let's move to one or two interesting topics that we're supposed to discuss today. So now, today we just want to discuss small basic things, something very, very basic, but very strong, which you may not strike you throughout your program, but these are very basic questions which are asked by your interviewers. So what is confidence level and interval? Very basic, what is confidence level? We all, every day we talk, I'm this confident. I'm this confident. I'm 95% confident. I am 80% confident. I'm confident in 95% confident that I will get a score of 90% in my test. That is the confidence level we are talking about in data and in statistics. And then what is a confidence interval? You remember we had talked about the data or the empirical very basic thing. This is my normal distribution. Okay. This is my normal distribution. This is standard deviation, which we will learn. Don't worry. My 95% of my data are, 68% of my data are between 1 and -1 standard deviation. Don't need to learn all these things right now, just trying to tell you something. 95% of my data values are distributed between -2 and 2 standard deviation from the mean. This is my mean. This is my standard deviation 1, standard deviation 2, standard deviation 3, standard deviation -1, standard deviation -2, standard deviation -3. So 68%, there's a universal truth. Okay, must remember 68% of my data under a normal condition should be distributed between -1 and 1 standard deviation from the mean. 2%, 95% should be between 2 and -1. 99.7% should be between -3 and 3 standard deviation. Remaining out of this 100 minus 99.7 something, the remaining are defect. That is a risk. That is a defect, which we will learn later. So when I'm talking about 68% confidence, 95% distribution, I'm talking about my confidence level. I'm saying at 95% confidence, I am saying that my data will be distributed between 2 and -2. So in probability, whenever we are learning probability, whenever we are doing statistics, remember we are working on probability. We can never be 100% right. Never. If you are 100% right, you are God. That is why when we work on a sample, when we work on our statistics or probability, we are always up to 99.99999. We are always between 0 and 1. Remember, between 0 and 1. We are never 0, we are never 1. If you are 0 or 1, it means you are true and you are God. That is why when we say that with 95% confidence, if I'm saying I will get a score, or my examination score will be, will be distributed between 80 and 85%. I'm saying this at 95% confidence level. It means my data distribution, assumingly, will be between -2 and 2. Now, if I increase this to 99%, it means I'm increasing this towards -3 and 3. It means my confidence interval will widen, because this is over here. Now this is widening up. My data distribution is between -3 and 3. My standard deviation is increasing. My standard deviation is increasing. So my confidence interval will widen up. It may be between 80 to 87. So the thumb rule is, when your confidence level increases, your confidence interval also increases. And this is the basic thing I wanted to speak with you. And we will learn all these things when we move ahead with our program. As we proceed, we will learn more and more basic and the concepts. P-value, is the pillar or the foundation or of any statistical analysis or data science, machine learning, artificial intelligence, whatever you say. P-value is nothing. It is a probability value based on which we decide whether it's a success, whether the event is success or a failure, whether I reject something or I accept my test, whether whatever I'm assuming is true or is false. That is the p-value which is used in the hypothesis testing. And when we learn hypothesis testing, we'll be spending good amount of time, because that is again a pillar which needs to be very, very strong for you, very, very strong. So we will spend a good amount of time on maybe 2 sessions or something on hypothesis testing. And then we'll be learning about the p-value. Why is the p-value very important? How do we interpret p-value? How do we look at p-value at different situations? And why p-value with different, a p-value is also called the lowest value of the significance level, and why different significant values or levels are different. How do we say that p-value of 0.001 is different from 0.004? All these things we will learn. In the meantime, please do explore yourself. Do try to make some research on whatever things we are talking, so that because of the time limit, we may not be able to cover everything in detail. Okay. But the objective of these 3 sessions are to tell you what data science is all about, how you should select your programs in future, how you should explore, what are the modules you should learn, what are the foundations, the basics that you must focus on, and how do you prepare yourself for interviews, and what are the topics which are important in the field of data science, machine learning, artificial intelligence. So we shall definitely have time limits, but we'll try our best to cover as much as possible. Any questions so far before we call it a day? If you watch the video again, you'll be able to recall what we have learned. So must watch the videos. Any question? No question? No interaction?
Hello, sir. Hello.
Sorry?
Sir, I want to know that along with statistics, what are the other mathematical concept one should know to become a data analyst? Are there any other mathematical concept one should learn?
I'll tell you one thing very honestly. Since we are working on R and Python, okay? Since we are not using a pen and a paper to write down the formula, honestly speaking, you don't really need to understand too much of mathematics or statistical formula. What you need to understand how R or Python is computing in the background. What are the parameters that's talking about? What are the universal? What are the thumb rules? Or what are the basic foundation, which are the what we call the thumb rule or the universal truth? You don't need to learn calculation, trust me, because R and Python, the way they compute in the background, it is impossible for you and me to learn them. It's good that we know mean, median, mode, we know how to calculate linear regression equation. That's it for now. You don't, I know, in my career, I didn't require anything, I didn't require to learn anything additional mathematics or statistics. Otherwise, you are always welcome to learn. You can always master. The more you learn, you'll become a master. Yeah, Dr. Sharma's Majid. Yes. Dr. Majid, please. Any other question before we call it a day? Fine, guys. Thank you so much for your time. And keep on learning, keep on watching the videos, keep on exploring more and more sources. And you can refer to all our reference videos. As I said, work hard. Without hard work, you will not get anything. You watch YouTube, you watch Coursera, you do anything. Without hard work, without a coach, without a mentor, you will not be able to achieve what you want. Okay, and this shows from a group of 180 people, I can only see 23, 25 people. So this is also a reason why a coach like me or mentor, of people, many institutes, not only me, many people who are offering you free services to coach you, support you, why they get demotivated? Because it's not that we don't want to do it, it's that we don't get that level of interest from the participants. So gradually what happens, we start getting into a mode, it's no, it's okay. People don't value free services. Okay, so we call it a day. Thank you so much for your time, and we'll meet again on Monday.
Sure,
Okay,
sir.
good night.
Thank you. Thank you. Good night.
Good night.
Thank you.
Thank you so much, sir.
Thank you so much, sir.